ready for a fascinating demo on multimodal AI. Our next speaker is Sahana Venkatesh. Sahana will present Image Inside AI, Semantic Photo Search with Gemma, highlighting how Gemma can be used as a single, powerful open source model to enable both vision and language capabilities for intuitive photo search. Prepare to be impressed. So, you're welcome. Please.
Awesome. Thank you so much for having me here. I'm Sahana. I'm a software engineer at Way. We are based out of London. So today we are going to do a have a really fun and hopefully a very insightful presentation as well. So I just want to present one of the works of how we can leverage a model that can understand vision and language to create a tool that can fulfill like a personal need for us. For example, most of us have used Google Photos or Apple Photos, and getting the relevant photo we need to show having a personalized search experience is something I feel like these applications are lacking. We are in need of like a real world application that can help a user to get the content they need using natural language as a way mode of communication. So this is where I think Gemma and like models that can have a unified language and vision capabilities shine out as a lot. And basically the idea and the theme is so that we search through our memories using the way we remember them and not by using their file names or location. Let's get started. Overall, I believe if there's like few things we walk away from this presentation, it would be one question choices and question basically why is something there. So to understand why is something there, first we need to like basically sort of understand what we are trying to do. So here our objective is to build a system that does the searching for us. There are there are like two workflows that are part of it. One, there is the search workflow that basically helps the user to find the image of interest they need. And there is also another workflow where the user would upload the images they need to the system, so that the later when the user is like trying to search through the images, they are retrieved from there. So let's basically start from the user journey, like how they move through the system. First, to retrieve an information, it has to exist in the first place. So basically the user uploads their image, and to like the claim that we would try to semantically match the image to what the user is searching for is a strong one. So to semantically match an image, we need to extract the semantic information from the image. That's where models come in. We basically get the description of the image along with the tags and the location from the image metadata. And we store like the tags, the description, and the location based metadata in a db, like think of it as a postgres db. And we store the image itself in a blob storage. So the reason, like I mentioned earlier, it's very important to question why we are doing the things that we are doing. So basically, by storing the metadata or tag information, which are in form of text and therefore can be structured, we can store them in like Postgres databases that basically are specialized and very optimized for like structure-based searches. And images are quite unstructured and could be like large in size. So it makes sense to like basically store them in a blob storage. This is a very common pattern across like ml design systems, that we basically store unstructured data such as audio, video, or image in a separate storage called blob storage, and reference them by using their URL in the Postgres database. Like I mentioned, the we would like to build a system that retrieves the information from for our user faster. So it makes sense that uh, we use a system that's optimized for structured searches. Second, the second workflow is basically the one down here is when the user searches for their image of interest. Like all So what happens is that because in the first step we have nicely basically split the information from our image, we have extracted the tags, the location metadata from the image. We can easily like do some sort of a semantic matching between the query the user submits and the information that exists already, and get the relevant information for the user. The images whose metadata matches what the user is requesting, we can basically get those images for them. So yeah, and I went through it overall. I went through the project overall, but I do want to specifically call out on like the technologies that are being used, because I it'd be really nice if people who are watching this, or like if you come across this, to like replicate it in your free time, because yeah, sorting out images, sorting out a gallery is a problem that could whose solution could benefit all of us. So like I mentioned, the major changes, major technology introductions I'm making is that basically highlighting that the images are stored as a blob, in a blob storage, and like extracting the description of an image along with the tags is done by Gemma. And the way I'm doing it at the moment right now is I'm basically using Grok. Grok provides like a unified interface. Basically, when I started with this project, I started using Llama. But because I was using Grok, I could switch the model that's happening behind the scenes, and basically rest of the flow remains the same. And in addition to that, there are other optimizations that could be done. Basically, we can deploy this app online, and many users can basically interact with this particular app. And because you're using a backend such as Grok, it can scale according to like how many people are interacting with it. And finally, the information, the Postgres database that I'm using is Superbase. um, Yeah, and I thought it'd be fun, to even show like a basic small demo of this application. So I had built this using Vercel. So I'll now just move on to my other tab to kind of show how this web app looks like. Um, I hope you guys can see my application. So like I mentioned, I built this using Vercel, and yeah, I had uploaded like a couple of images earlier. So one of the nice thing of like building up a personalized image search experience for ourselves is that we can add our own notes to it. Like for example, imagine uploading like a vacation pic. You can add like notes that basically, this is when I went to Bali, for example. Like this will basically help in the retrieval state, so make sure that the relevant information is retrieved from it. So very cool thing here is that I don't know how many of you are out there, but then like Demon Slayer is like a cartoon I watch a lot. So I have like a couple of images from Demon Slayer, and I have a very random image. So here is where we can like search by your own tags, and I'm just choosing Demon Slayer. And it basically retrieves two images for me, because it has some tags and some notes that basically has that basically has my query text in it. And I can also try uploading some random images. uh, yeah, why not this one? This is like a family picture, and hope the demo works. I just remove the query from here. Let me try again.
I think maybe you need to share other screen because for now we see just your presentation.
Oh,
Mm,
thank you.
AI-powered page. So share screen, click button share screen and choose what part. Oh yes, now I can see.
Awesome. Sorry about that. Yeah, I was just like demonstrating like this app. Like there are like couple of images from it had uploaded earlier. So there are like a few images from a cartoon which I like a lot, which is the Demon Slayer. So here I can the idea behind this personalized experience is I can like basically search for Demon Slayer and it will like pull up these two images for me. And you notice that I had like some Paris pics. So yeah, it pulls up. It's basically the same image, and these are all like AI generated description. This is really cool, right? Like it's a night out. It's a dark background. It's actually this is also really interesting because models can only generate the description and tags from what it sees, but it doesn't know that I we took this picture in Paris, and it doesn't know that like the person next to me is my sister. These are something that the user can add as notes, and this will be pulled up when this will be pulled up like when we are like searching through the image. Let me try to like add one more just to um, this is where like we can add personalized notes about the image. Takes few seconds to run. No, it didn't upload. Yeah, I'll try to debug it later, like issue of live demo, I guess. Cool. Let me just move on to like to share more information on like how retrieval works. Uh, like I mentioned, there are two things that are important. We have basically an images table where in this particular thing we basically store the information of the image, the notes, the AI description, location, and date. And there is also like a tags table where we store like the tags that are generated for the image along with the image ID. During retrieval, like it's also really cool to understand like how this actual retrieval will work. There's a bit of like multi-field filtering that's done behind the scenes. The query which the user enter is matched against the tags it's searched for in the description, the location, and the date. The images that basically show positive signal across these multiple fields are returned back. Before they are returned back, they are sorted by the date, so that we get the most relevant or the most recent images first. And it's also important to think about performance when you're building applications. Having idea that we can basically separate out the tags and location will greatly help us, because when you're like trying to search for Paris pictures or Bali pictures, having an index defined on those fields helps to like retrieve the relevant images or relevant information faster. And finally, a very important concept is the idea of pagination, because it takes a lot of effort to like download images and like download retrieval images. What we can do is like what like other social media apps do for us, like basically just display the first 20 results or first 10 results, have them ready to go. Only when the user wants to like pursue this further, like by clicking next item for example, then we can retrieve the next 10 set of images for us. And finally, there's also an important idea of a join I want to like bring up, because we join things on like image ID. The idea of like having joins is that there is one simple metadata table, and there's another really big table. By doing our searching, or by doing our finding out the rows of interest on the metadata table, we don't have to go through the entire big table. We can basically just query those rows in the big table that are relevant to us, and we do that by using joins. And finally, I just also want to like end this by asking a quick question to everyone in the audience, like, is this actually RAG? Well, we do use this is a very important question to ask, is because a lot of times we are introduced to technologies, and we try to like we basically try to digest information that's presented to us, but do not take the time to like actually question it. This is not exactly RAG. That the solution, at least the implemented in front of you right now, is not exactly RAG, and that's because even though it uses like search, which we expect in a RAG system, a search system becomes a RAG when if there is an LLM in it. So basically, in this particular design, the images are retrieved to the user from the database itself. However, for it to be a RAG, there should be an LLM between the user facing UI and the database. And the LLM would be the one that would get the input from the database, does some operation on it, like, beautify it or something. And then the LLM output is what presented to the user. This is basically. What will make a system RAG. And given we are not using this in this particular implementation, it's not RAG. uh, that's the presentation. I'm happy to take any questions.
So, did you finish with your presentation? Okay. No, I see that we haven't any questions, so